All right, let's dive into an idea that is going to sound a little wild at first. What if all the stuff in the universe, you, me, the planets, everything, isn't made of tiny little particles at all? What if it's actually just space-time tying itself into knots? It's a concept that could literally change how we look at everything.
So let's just start with this one, core question. Chew on this for a second. What if matter isn't an object in space, but is actually something that space is doing? Forget the idea of space as an empty stage. What if the stage itself is the only actor and all the things we see are just part of its performance? That one little shift in thinking, well, it unlocks a whole new way of looking at reality. So to really get this, we've got to completely rethink what space is. Seriously, it's not just some passive, empty void. In this picture, space is the star of the show. It's the only thing that's truly fundamentally real. Okay, so here's the breakdown. On the left, you've got our normal, everyday view of reality, right? Space is the stage, and matter, all the particles and stuff, are the actors moving around on it. Simple enough? But on the right, that's the new framework. Here, space is the actor. It's the only one. And matter, that's just one of its many performances. It's a total flip of how we usually imagine things. So if space is the only thing that exists, what is it? Well, the model calls it an oscillatory phase field. That sounds complicated, I know. But just think of it like a universal ocean that fills absolutely everything. And this ocean isn't still. It's always vibrating, always moving. This isn't empty space. It's a living, dynamic medium that makes up the entire universe. Right, so if everything is just this one big vibrating field, where do things come from? How do you get a planet or a person? Well, the answer is kind of beautiful. They aren't things at all. They're just geometry. So in this framework, what we call a particle is actually a topological soliton. Or to put it way more simply, it's a knot. Just imagine a little whirlpool forming in that universal ocean. A vibration gets twisted up on itself so tightly that it becomes a stable, self-contained pattern that can't easily untie itself. It's not a separate little speck floating in the field. It's a part of the field that's just behaving in a very specific, persistent way. It's trapped geometry. And that leads to this really simple but profound statement. Just let this sink in. Particles are not things. They are trapped geometry. Everything you think of as solid, your desk, your phone, it's not made of tiny solid bits. It's just the shape of space-time, twisted and locked into a stable pattern. Wild, right? So you might be wondering, okay, but what about properties like mass and charge? Well, this is the really elegant part. They aren't things that a particle has, they're things that the knot is doing. See, a free, simple vibration in the field just travels like a wave of light. It has no mass. But the second you trap that vibration, you localize it into a knot, that self-contained energy, that resistance to being moved, well, that's what we call mass. And the charge, that just comes from the direction of the twist. Is it twisting clockwise or counterclockwise? That gives you a positive or negative charge. It all just emerges from the geometry. And here's where this idea gets really powerful. A good theory doesn't just explain one thing. It sets off a domino effect, right? You push over one big idea, and suddenly a whole bunch of other mysteries just start to click into place, one after the other. So let's play this out. Let's just accept the premise for a minute. If matter really is just a knot in space-time, then suddenly gravity isn't some weird, mysterious force pulling things together. Nope, it's just the natural tendency of the space-time field to flow downhill toward the densest, most tangled-up knots. It's like water flowing into a dip in the ground. There's no spooky action at a distance, just the field itself trying to settle. And if you take that to its absolute extreme, you want to know what the ultimate, most over-twisted, tightest possible knot is? You guessed it, a black hole. It's a region where space-time has become so incredibly knotted up that it enters a whole new state of being. So check this out. In this view, a black hole isn't a dead star sitting in space. It's a region where space itself has become so condensed that it's in a state of total phase lock. The vibration is so intense, so self-trapped, that it's geometrically impossible for any wave to propagate outward. It's not that light isn't fast enough to escape, it's that the very geometry of space forbids the concept of out. Okay, so let's pump the brakes for a second. This is an absolutely mind-bending, powerful idea, but And this is super important. We have to be brutally honest about where it stands today in the scientific community. It's not a proven, mainstream theory. Not yet. Think of it more as a foundational idea, a whole new lens to look through. So let's look at the report card here. Is the idea logically consistent? Yes, absolutely. It holds together. Can you describe it with rigorous math? Yep, you can. Does it play nice with our two biggest theories, quantum mechanics and relativity? Amazingly, yes, it seems to. So it's ticking all these really important boxes. But here's the big one, the one that really counts. Has it been experimentally proven? And the answer is, nope, not yet. It still needs to make a unique prediction that we can actually go out and test.
And so that kind of leaves us with this final massive thought to chew on. If this way of looking at things is right, if all of reality, matter, energy, everything, is nothing more than the incredibly complex vibrating geometry of space-time, then what does that make us? Are we just really, really complicated, self-aware knots in the fabric of existence itself? Something to think about.